Hello everyone, my name is Saili Kadam. In this video, we will be discussing about support vector machine. So again, it is a supervised learning algorithm. So let us study about support vector machine. So again, it is a supervised learning algorithm which we can use for both classification as well as regression. But mostly or mainly we use SVM for classification. It is a very important thing. We prefer SVM for classification. So let us take an example and understand how exactly SVM works. So as usual, let us take an example that we are given a data set which has the data of students. So there is first student who studies for 2 hours and he is failed. So basically we have features as the number of hours the student studies. Again we have a second student who studies for 3 hours and again we can see that the student is failed. Then we have a third student having 4 hours of studying and still he is failed. Fourth student studies for 5 hours or let us say 6 hours and that student is pass. Then we have fifth student who studies for 7 hours and even that student is pass. So let us say we have this data set. Now if we are applying support vector machine, what exactly we will be doing is we will try to plot it. So basically SVM performs graphically. So the graph will look somewhat like this. So it will be like if the student studies for 2 hours the student is failed. Then the student studied for 3 hours, again the student is failed. Then 4 hours, again the student is failed. Then the student studied for 6 hours. Then he is pass, and for 7 hours also the student is pass. So this category is fail and this one is pass. Now let us say if a student new data point, that is a student studying for 4.5 hours ka, so it will lie somewhere here. So there is a probability that the student is failed. Then there is another student who studies for 5.5 hours, so it is close to this. So it may be like the student is pass. So we need to come up with a decision boundary, that if that means we need to come up with a line. So if the data point, the new data point comes after that line, lies after that line, the student is clearly pass, otherwise the student is fail. So the main aim is to find out the decision boundary, that if the data point lies after this or before this, above this, below this, then this will be the decision. So we can do one thing, we can create our decision boundary somewhere here at 5, and the aim is to maximize the margin. So margin is the distance in between the decision boundary. So this line we call it as a decision boundary and we need to find out the decision boundary. So the aim is to maximize this, so the distance should be maximum. These are the nearest data points, 4 and 6 are the nearest data points, and we need to find out the decision boundary in such a way that the distance is maximum. So we will have a decision boundary at 5, and then if the student or the new data point lies like if the student studies for 5.8 hours, so clearly we can say that the student is fail. If the student studies for 5.3 hours, then we can clearly say that the student is pass. So this is how support vector machine or SVM works. There are some of the important definitions that we need to take care of when we work with SVMs, which we are going to discuss in the upcoming slides. But the basic working is to come up with a decision boundary, and the distance in between the nearest data points to the decision boundary and the decision boundary should be maximum. We call it as margin. We will discuss it in the next slide. But this is how SVM works, that we need to come up with a decision boundary which will give us the best result, or which will give what exactly the new data point from which class it will belong to. So this is how the SVM works. So we have some of the important definitions that we need to cover in SVM. So the first definition is hyperplane. So basically the decision boundary, we call it as hyperplane, which basically separates the classes. So if we have two classes, we will draw one hyperplane. We call it as decision boundary as well. So that hyperplane, it will clearly differentiate or make the classes, divide the classes. This is hyperplane. Then we have margin. So the margin is the distance. As I said, that our aim is to maximize the margin, the distance in between the nearest data points to the hyperplane. So there are the 4 and 6 in our example, where the nearest data points to the hyperplane. So we need to maximize the distance in between the decision boundary and the nearest data points of each class. So that is basically margin. Then we have maximum margin. So basically, as I said, the aim of SVM is to maximize the margin. That is, we can draw multiple lines. So in our examples, in between 4 to 6, we would have drawn multiple lines. Why did we select 5 as the separating boundary? It is just because it is equidistant from both the ends, which makes, we can say that it will give us more accurate results. If we make decision boundary at 5.5 or something, so the result may get biased. That means if a student studies for 5.1 hours, the student is fail. Or if we have decision boundary at 4.8 or something, then even if the student studies for 5 hours, it will be considered as pass. So we need to maximize the margin in such a way which gives us the best results. Then we have support vectors. Support vectors are the data points. So basically margin, as I was saying, that we need to maximize the distance in between the nearest data points and the hyperplane. So the nearest data points are support vectors. The nearest data points from each class, we call them as support vectors. Then we have hard margin SVM. So basically, when we have data which is linearly separable, that means we can clearly come up with a decision boundary. That data we call it as hard. So basically, that is a hard margin SVM when we have linearly separable data. So clearly we can have a decision boundary. So there is no overlapping in between the data. We can clearly differentiate two different classes. That is hard margin SVM. Like in our case, we were clearly having that if the student in the data set, in the training set, we clearly had it that if the student studies for 4 hours, we said that the student is fail. If the student studied for 6 hours, the student was pass. So it is clearly, just in case, let us say if we have some overlapping in between the data, if the student studies for 4 to 6 hours, the student is fail. If the student studies for 5 to 7 hours, the student is pass. So there we can say that the data is overlapping. It is not separable. Linearly separable data is not present. We cannot differentiate in between the classes where the student is pass or fail. In that case, we can't just plot a line and say that if the student lies after this is fail, if the student lies behind it, this is fail. It can't happen. So hard margin SVM is when we have perfectly separable, linearly separable data where we can easily come up with a decision boundary and we can have the aim to maximize the margin. That is basically hard margin SVM. Then we have soft margin SVM. Soft margin SVM is when we have some overlapping data or where we don't have, cannot clearly draw a line and come up with it. Like if we have overlapping intervals, how to decide that after what point we need this? So that is soft margin SVM. In hard margin SVM, we have linearly separable data. In soft margin SVM, we do not have linearly separable data. There we have some overlapping data which we cannot perfectly plot a hyperplane there. If we cannot plot decision boundary clearly there, that is soft margin SVM. So these are two types of SVM, Depending on the data set that we have, we should use any of this. But the basic principle or the basic working of SVM is we need to come up with a hyperplane so that we could differentiate, we could classify how exactly or to which class one thing will belong to. So the soft margin SVM, what will they do? They will obviously, they won't give us directly a line, but we want the line. So for that reason, so this is basically a thing that we don't want. So for that reason, we have a concept called as kernel. So basically kernel is a mathematical function, as we all know, which we used when we don't have a linearly separable data. We use kernel function which transforms the data into higher dimensions, so that basically it makes the data linearly separable. There are different types of kernel functions also. Depending on the data set that we have, we use appropriate kernels, like we have linear kernels. So we will have a separate video where we will be only discussing about kernel and its types. We have we have soft margin SVMs where we don't have linearly separable data. We cannot come up with a hyperplane. So in such cases, we use kernels, which kernel make the data or try to make the data linearly separable so that we could draw a hyperplane. And in upcoming videos, we will be talking about kernel and different types of kernels and when to use which kernel. So these are some of the important definitions that we need to know while we are studying SVM. Then we have, so this is basically graphic representation, or it is basically the first one shows us that we have one hyperplane. So this is an hyperplane. This is, so basically this is first class, this is second class, sorry, this is the second class, it is mentioned in the label, and this one is first class. So this is the decision boundary. How did we come up with this decision boundary? If we observe, it is somehow central point in between. So basically this will be somewhat margin, this line. So this is somewhere, it lies, it is the central point. So this is the hyperplane, we call it as decision boundary. Then we have margin. Margin is the distance in between the nearest support vectors, the points that lie close to the decision boundary. So the distance in between them is margin. So distance between support vectors and the hyperplane. Then we have support vectors, the points that lie close to the decision boundary. So in first data or class 1, this point is closest to the decision boundary, and in the second class we have these two data points which are close to the decision boundary. So these are the support vectors. So I hope you understood the concept of hyperplane, margin and support vector. It is very important when we talk about SVM. So the working of SVM, as we have already discussed, it is that first we collect the training data, then we plot. Without plotting, without using graphs, we cannot use SVM. Then we calculate or we find all the possible hyperplanes. So there may be n number of hyperplanes that we can draw. So we find out all the possible hyperplanes. Then we calculate the margin. The aim is to maximize the margin. Then we select the hyperplane that has maximum margin. This is the aim. Then we train the model, and then we classify new data points. We have already discussed one example about this, and I think we know how clearly SVM works. Then we have assumptions of SVM. So what are the assumptions of SVM? The first one, very important, the data should be separable. The classes should be separable, and just in case, this is a very important assumption when it comes to SVM. We want our data set, or we want the classes to be linearly separable. Just in case if they are not, we use the concept of kernel and we make them separable. Then we should have clear boundaries, then and then only we can plot that hyperplane. So that is also one of the assumptions. then data should have minimal noise and outliers. So when we have outliers and when we have noise in the data set, then the position of hyperplane will change, because the aim is to maximize. Let us say we have, let us draw something here, and this is class 1. So if we see that most of the data points lies close to each other, but there is only one data point which lies here, so clearly this one is outlier. All other data set lies close to each other, but this one is here, so it is an outlier. And we have another data set where we can see the same picture. Let us say this data set don't have an outlier. So when we are trying to plot a hyperplane, in that case, so if this point was not present, so we would have considered hyperplane somewhere here, and that was the maximum margin. But because of this point, the position of hyperplane will vary. So we should try that the dataset should not have outliers and noise present in it. Then we should not use SVM when the data is very large. So when we have extremely large data, there is a very high chance that we have outliers present in that data set. So then again the position of hyperplane changes, and when we have an extremely large amount of data, then it becomes difficult to plot each and every data point there, and till the time we don't plot a graph, we won't be able to come up with a hyperplane. So when we have extremely large data set, we should avoid using SVM. When we have small or medium sized data set, we prefer SVM. Then we have advantages of SVM. The advantages are like, when we have high dimensional data, that means we have multiple features, we can go for SVM. Then as I said, when we have small or medium sized data sets, we can efficiently use support vector machines. And if the in real life data is not always linearly separable, or mostly it is not linearly separable. So even if the data is linearly separable, even if it is not linearly separable, in both the cases we can use SVM. Even if we have studied soft margin SVMs where we use kernels, so even if we don't have data which, like, we are working with non linearly separable data, in those cases we can first make them linearly separable and then we can use them, so it is effective for both. Then we have disadvantages. Disadvantages is, when we have large data set, it becomes computationally expensive because we need to plot each and every point. So this is that it becomes computationally expensive. Then choosing right kernel is difficult. As I mentioned earlier, there are different types of kernels which we are going to study in our upcoming videos. So in all of them, what happens is, there are multiple kernels. So which one to use and which one will be suitable for our dataset is quite difficult to come up, or quite difficult to choose. And then the last disadvantage, so there may be multiple disadvantages, but these are important ones. So when we have classes, we have significant overlap in between. Up to some extent we can avoid, we can use kernels and we can avoid. But if the data is, the classes are highly overlapped, in those cases this we can still perform, we can still use kernels, we can make them linearly separable, but still the effectiveness won't be the same. So these are some of the disadvantages of support vector machine. Then we have applications. So as it is a supervised learning algorithm and we mostly use for classification, then obviously when we say classification, spam email detection is something that every algorithm we can use all the classification algorithm when it comes to email spam detection. Then we can also use it for image classification and face recognition. So this was all about the support vector machine. I hope that we have covered all the possible things and everyone has understood that what exactly we discussed. And so this was all about SVM. I think most probably we will be discussing type of kernels in our upcoming videos. So that's all for this video. Thank you.